Right now, somewhere on this planet, a human being is crying. Not because they're hurt, not because something's in their eye, but because they felt something so big, so overwhelming, that their body decided the only appropriate response was to leak salt water from their face. And here's the thing nobody really talks about. As far as we can tell, no other animal on Earth does this. Not gorillas, not elephants, not dolphins, despite what that one viral video tried to convince you. Emotional tears, the kind that come from grief or joy or heartbreak, seem to be uniquely, weirdly, almost impossibly human. Think about how strange that actually is. We're not the strongest species. We're not the fastest. We don't have the best eyesight or the sharpest hearing. But somehow we're the only ones who cry when we're sad. Elephants mourn their dead. They stand over the bones of family members for hours. Dogs whine when they're separated from their owners. Chimpanzees show what looks exactly like grief, but none of them produce tears because of it. So what happened to us? What changed somewhere in our evolutionary past that made salt water streaming down our cheeks into a form of communication? If you're using this to fall asleep, hey, that's exactly why I make these. So subscribe maybe, and tell me where you're listening from and what time it is there. I actually read these comments. Last week it was Tokyo at 2 a.m. and Toronto right after lunch, all within the same hour. It's kind of wild thinking about how many time zones are drifting off to this at any given moment. Now, here's where this gets genuinely fascinating. Scientists have been trying to crack this mystery for decades, and honestly, they still haven't fully figured it out. We're going to dig into the actual biology of tears, the tiny glands, the specific chemical cocktails your body brews up when you cry from emotion versus when you just yawn too hard. We're going to look at what other animals are actually doing when people swear they saw an elephant cry or a dog tear up. Spoiler, it's usually not what you think. And we're going to walk through the leading theories, because there are several about why humans specifically evolved this strange, vulnerable, oddly beautiful behavior. Some scientists think it's about bonding, some think it's about survival. Some think it might not even be one single answer at all. Before we get into it, if you're the kind of person who likes falling asleep to a good mystery, do me a favour and follow this on Spotify. It's completely ad-free over there, so no random interruptions yanking you out of your sleepy brain fog at 3 a.m. And if you've got 30 seconds and you're feeling generous, a 5-star review helps more than you'd probably guess. It's basically the digital equivalent of someone recommending you to a friend. So get comfortable, because we're about to explore one of the strangest, most uniquely human mysteries there is. A behaviour that seems so simple on the surface, crying, that we barely think twice about it. But the deeper you look, the weirder and more unexplainable it gets. Before we go any further, we need to stop and ask a question that sounds almost embarrassingly simple. What actually counts as crying? Because here's the thing. When people say humans are the only animal that cries, they're not talking about making sad noises. They're not talking about whimpering or howling or making that pathetic little sound your dog makes when you leave for work. They're talking about something much more specific and much stranger. Tears, actual liquid produced by actual glands, streaming down an actual face triggered by an emotional state rather than a physical irritant. That distinction matters more than you'd think, because once you start picking apart the definition, the whole picture gets a lot more complicated. Let's start with the basics. Crying, in the way most people use the word, is actually a bundle of several different things happening at once. There's the tears themselves, the literal salt water production. There's the facial expression, the scrunched up eyes, the trembling lip, the flushed cheeks. There's the vocalization, the sobbing, the gasping, the sounds that come out of your throat when you're really losing it. And then there's the context, the reason behind all of it, the emotional trigger that supposedly ties the whole performance together. Most animals can do some of these things. Plenty of animals vocalize when they're distressed. Plenty of animals have facial expressions that look like sadness to us, even if we can't be totally sure what's happening inside their heads. But the actual production of tears in response to an emotional state, that's the part that seems to be almost entirely weirdly human. This is where a lot of confusion comes from, honestly. When people say gorillas don't cry or elephants don't cry, they don't mean gorillas and elephants don't feel sad. They clearly do. Elephants have been documented standing around the remains of dead herd members for days, touching the bones with their trunks, going quiet in ways that look a whole lot like grief to any observer. That's an emotional response. That's real. Nobody's arguing animals don't have feelings. The argument is much narrower than that. It's specifically about whether feeling something sad triggers the physical release of tears. And so far, as strange as it sounds, the answer for almost every species we've studied is no. So to actually understand this mystery, we need to get precise about what tears even are. Because it turns out your eyes are producing tears constantly, all day, every day, whether you're sad or not. Most of the time, you don't even notice it's happening. Scientists generally break tears down into 3 categories, and only one of them has anything to do with emotion at all. The first type is called basal tears. These are the tears working in the background right now, whether you're thinking about it or not. Basal tears are the thin, constant layer of moisture that keeps your eyes lubricated, protected from bacteria, and functioning properly. Think of it like an assembly line that never stops. Your eyes are delicate pieces of biological equipment, and without a steady coating of moisture, they dry out, crack, and become vulnerable to infection within hours. Basal tears are your eyes' built-in maintenance crew, quietly doing their job in the background, while you go about your entire day completely unaware. No emotion required. No sadness, no joy, nothing. Just basic biological upkeep. The kind of process evolution built into nearly every creature with eyes that need protecting. The second type is reflex tears. These are the tears that show up when something physically irritates your eye. Chop an onion and your eyes start burning. Get a speck of dust in there. Take a blast of wind directly to the face on a cold day. Reflex tears are your body's emergency response system, flushing out whatever's causing the irritation as fast as possible. This is pure biology, pure mechanics, nothing emotional about it whatsoever. Your eye detects a threat, sends a signal, and your tear glands go into overdrive to wash the problem away. Interestingly, reflex tears actually have a different chemical composition than basal tears. They're more diluted, designed to flush quickly, rather than provide long-term lubrication. Your body, it turns out, is remarkably good at producing exactly the right kind of tear for exactly the right situation, without you ever having to think about it consciously. And then there's the third category, the one that makes humans so strange: emotional tears. These are the tears triggered not by physical irritation, not by dust or onions or wind, but by an internal emotional state. Grief, heartbreak, overwhelming joy, watching your kid graduate, getting terrible news over the phone, watching the ending of a movie you swore wouldn't get to you, and then absolutely getting got by it anyway. Emotional tears don't show up because something's physically wrong with your eyes. They show up because something happened inside your brain, some emotional threshold got crossed, and your body responded by producing liquid on your face. When you really sit with how strange that is, it starts to feel almost absurd. Feeling something intensely enough to leak fluid from your eyeballs is not, on the surface, an obvious biological strategy. And yet here we are, every single one of us, doing it constantly. Now here's where the science gets genuinely interesting. because emotional tears aren't just chemically identical to the other two types with different packaging. Researchers who've analysed tear composition have found that emotional tears contain higher concentrations of certain hormones and proteins compared to basal or reflex tears. Some studies have pointed to elevated levels of stress-related hormones like ACTH, along with certain proteins linked to pain regulation. This has led some scientists to a genuinely wild hypothesis that emotional tears might actually be a mechanism for physically removing stress chemicals from your body. Cry it out might not just be a comforting phrase your grandmother told you. It might be describing something literally happening at the molecular level. We'll dig much deeper into the actual chemistry later, because there's a lot more nuance and a lot more disagreement among researchers than you'd expect. But for now, the important takeaway is this. Emotional tears aren't just watered-down reflex tears. They appear to be their own distinct biological product, manufactured specifically in response to what's happening inside your head, not what's happening in front of your eyes. This is also where measurement becomes a genuine headache for scientists trying to study this stuff. How do you even quantify crying in a lab setting? Do you count the number of tears produced? The duration of the crying episode? The intensity of the sobbing? Researchers have tried all of these approaches, and each one comes with problems. Some people cry silently, tears just quietly rolling down their face without a single sob escaping. Others fall completely apart, full body shaking, gasping breath, the whole dramatic package, but produce comparatively few actual tears. Frequency is just as tricky. Some people cry several times a week. Others go months, sometimes years, without shedding a single emotional tear. And that doesn't necessarily mean they feel less. It might just mean their particular biology, their particular upbringing, or their particular threshold for emotional release works differently. Triggers vary wildly too. Grief is the obvious one, the one everybody assumes when they picture crying. But plenty of people cry from happiness, from relief, from frustration, even from anger. Weddings, reunions at airports. That specific kind of overwhelmed feeling you get finishing something you worked toward for years. All of these can trigger the exact same physical response, tears streaming down your face, even though the emotional experience behind them couldn't be more different. So when scientists say humans are likely the only species that cries emotional tears, this is the very specific, very narrow claim they're actually making. Not that we're the only animals with feelings, not that we're the only animals capable of vocalizing distress or displaying visible sadness. Specifically, that we appear to be the only species whose internal emotional states reliably trigger the physical production of tears through this third distinct pathway. Basal tears, sure, plenty of animals have those. Reflex tears, absolutely. Nearly every creature with eyes produces those when something's physically bothering them. But that third category, tears born purely from feeling something rather than experiencing something physical, that one seems to belong to us and us alone. And once you accept that distinction, the mystery only gets deeper. Because now the question isn't just why do humans cry? It's why would evolution bother building an entirely separate tear, producing system, one triggered by nothing more than an internal emotional state, when the two systems we already had seemed to be working just fine? That's not a small evolutionary decision. That's a significant biological investment. And to understand why our bodies might have made that investment, we first need to understand exactly how this system works, starting with the actual anatomy responsible for turning a feeling into a physical, visible, undeniably human response. If you want to understand why humans cry the way we do, you have to start with something deeply unromantic. Plumbing, before a breakup, before a funeral, before a Pixar movie wrecks you in the third act. there's a tiny piece of wet biological hardware sitting just above your eyeball, waiting to go to work. Each of your eyes has its own dedicated tear factory, called the lacrimal gland. It's tucked up under the outer part of your upper eyelid, kind of behind the bone of your eye socket. Most of the time this thing is operating on low power. It slowly secretes tears that get spread across the surface of your eye every time you blink, creating that thin, shiny film that keeps your cornea from drying out. It doesn't feel like anything, because it's always on. You only notice it when something changes. From the factory, the tears don't just sit there as a static puddle. They move. Every blink acts like a tiny windshield wiper and conveyor belt at the same time, sweeping the liquid from the outer corner of your eye across the cornea toward the inner corner, near your nose. There, another part of the plumbing takes over. 2 tiny openings called the puncta, one on the upper eyelid, one on the lower, each about the size of a pinhole. Those little puncta are the drain. They suck the tears off the surface of your eye and funnel them into narrow tubes called the canaliculi, then into a small reservoir called the lacrimal sac, and finally down the nasolacrimal duct into your nasal cavity. This is why your nose runs when you just have something in your eye, and you're definitely not crying about it. The system is literally designed so that tears exit through your nose, not down your cheeks. Under normal conditions, this plumbing loop is perfectly balanced. Lacrimal glands trickle out fluid, your eyelids spread it, the drains quietly pull it away. Basal tears go round and round, keeping everything moist and protected, and nobody writes poems about it. But that balance only works within a certain range. Push the system hard enough, and something interesting happens. When you chop an onion or get blasted with smoke, reflex tears crank production way up. The lacrimal glands start dumping out fluid much faster than usual. The drainage system tries to keep up, but it has a maximum capacity. There's only so much liquid those tiny puncta can move per second. Once tear production outruns drainage, the excess has nowhere to go. It pools along the lower eyelid, spills over the edge, and finally breaks free, running down your face. This basic overflow mechanism is exactly what emotional tears hijack. The visible crying we associate with grief, heartbreak, or overwhelming joy isn't just more moisture. It's a volume problem. Your emotional circuitry pushes the lacrimal glands into overdrive. The duct can't keep up, and suddenly you have literal evidence of your inner life leaking onto your skin. But the weirdness of human crying isn't just about quantity. It's also about quality. Those tears themselves are not just tiny drops of salt water. They're chemically complicated, and that complexity seems to change depending on why they're being produced. Every tear, no matter the type, is actually a layered film. On the very outside, there's a thin, oily layer made of lipids, secreted by special glands in your eyelids, called the meibomian glands. This oily coat slows down evaporation and keeps the underlying water from just disappearing into the air. Under that sits the watery layer most people picture when they think of tears, mostly water, plus dissolved salts like sodium and potassium, similar to a very diluted version of blood plasma. This layer is what gives tears their sting when they hit a cut or cracked skin. Closest to the surface of your eye is a mucin layer, produced by goblet cells in the conjunctiva, the transparent tissue covering the white of your eye. That mucin is sticky, helping the whole tear film cling evenly to your eyeball instead of beading up and rolling off. Together, these 3 layers, oil, water, and mucus, form a surprisingly sophisticated protective coating. Mixed into that watery middle layer is a small biochemical toolkit. There are proteins like lysozyme that can literally punch holes in bacterial cell walls, lactoferrin that binds iron and starves microbes, and secretory IgA, an antibody that helps neutralize potential pathogens. There are growth factors that help maintain the health of your corneal cells. There are enzymes that clean up stray debris. In other words, every blink is bathing your eye in a mild antimicrobial wash and repair solution. Basal tears lean heavily on this maintenance formula. Reflex tears adjust it. When your eye needs flushing, the system prioritizes volume over deluxe chemical packaging. Reflex tears tend to be more watery, more diluted, optimized for washing irritants away quickly, rather than sustaining long-term protection. You don't need a perfectly structured 3-layer film when you're trying to hose out an eyelash or a burst of chili pepper vapor. You just need flow. Emotional tears, though, are where things get really contentious and interesting. Several small studies going back to the late 20th century have claimed that tears, triggered by emotion, watching a sad film, recalling a painful memory, dealing with personal loss, contain higher concentrations of certain hormones and neurochemicals than either basal or reflex tears. People have reported elevated levels of stress-related substances like ACTH and prolactin, as well as differences in various proteins tied to pain modulation and mood. The popular version of this idea is appealing. Emotional tears as a kind of detox, physically flushing stress molecules out of your system. Cry hard enough, the story goes, and you're literally bleeding off biochemical pressure through your eyeballs. It's a tidy explanation for why people often say they feel better after a good cry. The problem is, as more researchers have looked at this, the picture has gotten messier. Some later studies find differences in composition between emotional and reflex tears. Others find smaller differences than expected, or results that are hard to replicate. The sample sizes are often tiny. People's emotional states are notoriously difficult to standardize in a laboratory. It's one thing to splash someone with onion vapor and measure the tears that follow. It's another to induce genuine grief on command and then collect it in a little capillary tube. So at this point, the safest thing to say is that emotional tears do appear to differ chemically. But how much, and in exactly what ways, is still an active area of debate. There are enough signals to make scientists take the idea seriously, but not enough clean data to declare a simple stress chemical outflow story as settled fact. Like most things in biology, it's probably more complex than a single neat function. Regardless of the exact chemistry, though, emotional tears share one crucial engineering trick with reflex tears. They have to overpower the drain to become visible. Plenty of emotional episodes never reach your cheeks. Your lacrimal glands might ramp up a bit, your tear volume might increase, but the ducts still manage to quietly siphon everything away. From the outside, no one sees anything. You just feel your eyes get wet or burn slightly. The kind of crying we recognize tears standing on the lower eyelid, spilling over, running in streaks. That's what happens when the input overwhelms the system. Your blinking can't spread it fast enough, the puncture can't drain it fast enough, and the excess rides gravity straight down your face. This is part of why crying on the inside is more than a poetic phrase. Biologically, there really is a continuum between subtle increases in tear production and the full visible overflow we associate with emotional breakdown. And then, layered on top of the plumbing, come the facial cues. Emotional crying rarely lives in the tear glands alone. The same brain regions that tell your lacrimal glands to ramp up are also talking to the muscles of your face and throat. Your brow pulls together, your eyes squeeze shut more often and more forcefully. Your breathing pattern shifts into sobs and gasps. Those muscle contractions actually help push more tears out by squeezing the glands and disrupting the smooth tear film, feeding the overflow even further. So what we call crying is really a coordinated event. A specialized gland, a drainage system with limited capacity, a chemically active fluid, and a set of facial muscles, all getting their marching orders from the brain at once. Tears don't just appear. They're manufactured, layered, moved, and finally allowed to spill when the system is driven past its original design specs. Once you see how much machinery has to come together to produce something as simple as a tear running down a cheek, the mystery deepens. Because now the question isn't just why humans make emotional tears at all, but why evolution would tune this whole network, glands, ducts, chemistry, facial muscles, so that an invisible maintenance fluid could turn into a highly visible social signal. To answer that, we need to look outward, at what other animals are doing with their own tear systems, and why almost none of them seem to cross that final, very human line. If you zoom out from humans and just ask, who else has tear glands? The answer is almost everybody with eyes that live out in the air. Birds, reptiles, mammals, even some amphibians all run some version of the same basic kit. A moist, transparent cornea is fragile and exposed. The solution nature keeps rediscovering is a lubricating, protective film that gets renewed every time the eyelids move or the nictitating membrane sweeps across the surface if you're a bird or a crocodile. In most animals, though, that system never becomes a billboard. Basal tearing, the low-level, always-on secretion that keeps the eye from drying out, is the default. Reflex tearing, the surge of fluid that flushes out dust, bugs, sand, or chemical irritants, shows up when things go wrong. Both are fundamentally local. They're about eye health, not communication. This is why almost every claim you've heard about animals crying in an emotional sense collapses the moment you look at the plumbing. Take the most famous example, crocodile tears. The phrase comes from medieval stories claiming crocodiles would weep while eating their victims, as if they were faking remorse. That sounded poetic enough to stick in the language, and now we casually accuse people of crocodile tears when we think they're pretending to be sad. But when biologists actually watched crocodilians up close, the explanation turned out to be a lot less Shakespearean. Crocodiles and their relatives have lacrimal glands and a third eyelid that spreads fluid over the eye. When they haul themselves out of the water and start tearing into food, a few things happen at once. Their jaw muscles contract hard, their breathing shifts, the ducts that connect the eye region to the sinuses and mouth get squeezed. The result is that fluid gets pushed out along the eyelid margins. Add air, evaporation, and maybe a bit of mucus, and you see shimmering wetness at the corners of the eyes. It looks like crying, but functionally, it's closer to drooling up top. There's no good evidence that crocodiles are feeling sorrow for the antelope they're dismantling. It's just the physics of glands, ducts, and pressure playing out in an unfortunate visual metaphor. You see similar misread crying in a lot of other animals. Dogs with big exposed eyes often get watery-looking faces. Sometimes that's just their basal tear film spilling over because the angle of their eyelids doesn't drain well. Sometimes it's a mild eye infection, an allergy or irritation from wind or dust. Brachycephalic breeds, the ones with very flat faces, are especially prone to it. Their tear drainage hardware is crammed into a shortened skull, so the fluid leaks onto the fur instead of disappearing down the ducts. Owners interpret the dark tear stains as sad eyes. A veterinary ophthalmologist sees chronic overflow and poor drainage. Livestock and wild herbivores can show the same thing for different reasons. Get a bit of plant sap, dust, or insect in the eye, and reflex tearing ramps up. On hot days, evaporation from that extra moisture can even help cool the eye surface, a tiny bonus feature. But stand on the wrong side of the fence and you'll see a cow or goat with wet lashes and assume it's crying. What you're really seeing is a cleaning cycle. Illness adds another layer of confusion. Viral or bacterial infections of the respiratory tract often inflame the tissues that line the eye and nasal passages. That swelling can partially block tear drainage, leading to watery eyes. Some parasites irritate the conjunctiva directly. Toxins, whether from plants, pollution, or chemicals, can trigger powerful reflex tearing as the body desperately tries to rinse them away. In all these cases, the animal probably does feel bad. There's distress, discomfort, maybe serious pain. You're looking at a miserable creature. But the wetness around the eyes is collateral damage from the immune system and the reflex arcs, not an evolved signal of inner emotion. Feeding can also produce eye wetting that looks strangely sentimental. In some mammals, chewing hard or straining the jaw increases venous pressure in the head and neck that can temporarily affect blood flow and fluid movement around the orbit. Coupled with facial muscle contractions, you can get a little bit of fluid expressed from glands near the eye. To a human brain tuned to see pathos in a single glistening drop, it's easy to read that as a moment of feeling. Biomechanically, it's closer to the way your nose runs when you eat very spicy food. So why are we so quick to insist that animals are crying the way we do? Because our brains are ruthless pattern matchers, and faces are our favourite pattern. From the moment we're born, we're locked onto eyes, mouths, and the configurations that signal emotion. That tuning is so strong that we project it onto almost anything with two dark spots and a line under them. Cartoon characters, electrical outlets, the front of a car. This tendency, anthropomorphism, is both a scientific headache and a powerful source of empathy. When a dog's eyes get shiny and its brows pull up, it punches the same buttons in us as a child, about to burst into tears. When a horse has a naturally drooping lower eyelid, we see melancholy. When a chimp's facial muscles arrange into something that looks uncannily like a human grief expression, we feel it as grief, even if the underlying emotional state doesn't map cleanly onto ours. Anthropomorphism isn't always wrong. Many animals clearly have rich emotional lives, and we'd be foolish to assume they don't feel fear, attachment, frustration, or loss, just because they express it differently. But when it comes to visible, overflowing tears as a direct output of emotion, the evidence, so far, is stubborn. Outside of humans, we keep finding eye wetting that serves local physical functions, lubrication, protection, cooling, flushing toxins, while the sad look is being painted on by our own brains. To really see what other animals are doing with emotion, we have to stop staring at their tear ducts and start paying attention to everything else, their voices, their posture, their social behavior. Because in almost every species we've studied, the main channel for emotional distress isn't liquid. It's sound and movement. If you follow that cue and listen instead of looking, a very different picture emerges. Across mammals and birds especially, the closest thing to crying isn't anything happening around the eyes. It's what comes out of the mouth and throat. Ethologists talk about distress vocalizations as if they were a single category, but in practice they're incredibly finely tuned. A baby mouse separated from its mother doesn't just squeak randomly. It produces ultra-high frequency calls, ultrasonic cries you can't even hear without special equipment. Those calls are so stereotyped that researchers can tell how cold, how hungry, and how alone a pup is just from the signal pattern. Infant monkeys do something parallel in a register we can hear. They have separation calls, pain screams, and I'm being handled too roughly protests that differ in pitch, rhythm, and duration. Mothers key into those differences with astonishing speed. In some species, a half-second change in the shape of the call is enough to flip a female from ignore it to drop everything and sprint. Birds push this even further. Nestlings of swallows, sparrows, and many songbirds emit begging calls whenever a parent lands nearby. The louder, harsher, and more frequent the call, the hungrier the chick tends to be. Parents adjust feeding accordingly. Playback experiments show that you can trick a bird into overfeeding and nestling just by making the begging call sound more urgent. It's a sound-based arms race. Offspring evolve, cries that are hard to ignore. Parents evolve filters so they don't waste effort on every tiny complaint. You can see the same basic logic in herd animals. A lamb caught in a fence, a young zebra separated during a stampede, a piglet crushed under a sow. Each has a specific high-energy distress call that slices through background noise and mobilizes the group. Other animals look up, orient toward the sound, and often rush to intervene, or at least investigate. The voice is the flare gun, and it isn't just the young who cry out. Adult primates give alarm calls that encode what kind of predator is coming, and sometimes even what you should do next. Meerkats, prairie dogs, and many social birds have different vocalizations for aerial versus ground threats. Some monkey calls distinguish a leopard from an eagle, from a snake. To the untrained human ear, it all sounds like panicked shrieking. To the animals, it's closer to a shouted sentence. Big cat. On the ground. Climb now. But sound is only half the story. The other half lives in bodies and faces. Watch dogs meeting each other and you'll see a whole dance of appeasement signals. Lowered head, tucked tail, ears back. Tongue flicks, turning the head or whole body sideways. Even brief submissive grins where the lips pull back to expose teeth in a way that looks scarily like a human smile. These aren't about eye wetness. They're about advertising intention. I'm not a threat, don't attack. Let's keep this safe. Wolves, hyenas, and many primates use similar postures. A subordinate animal might crouch, make itself small, avert its gaze, and present its side or rump, instead of staring head-on. The physical configuration of the body carries emotional data, fear, appeasement, deference. If the higher-ranking individual accepts the message, tension drains out of the encounter. Aggression drops without a single tear being shed. On the flip side, there are bonding signals. Grooming in primates, allopreening in birds, nuzzling and licking in ungulates. Two chimpanzees that have just reconciled after a fight will often sit close, touch, groom, and make soft vocalizations. Their eyes may stay dry, but their entire bodies are broadcasting, "We're okay." The relationship is repairable. Facial expressions play a role, but again, mostly through muscles, not moisture. Rhesus macaques have specific grimace faces when they're threatened. Dogs have what's been labelled puppy eyes, a raising of the inner brow that makes the eye shape closer to a human infant's. That expression reliably elicits caregiving behaviour from humans, and domestication studies suggest our own selection preferences may have amplified it over thousands of years. We weren't choosing dogs that cried. We were choosing dogs whose faces tripped our hard-wired responses to infant-like cues. All of this funnels into a key question. What actually triggers help across species? Again and again, the answer is some combination of sound, posture, and proximity. High-pitched, repetitive, noisy calls, small, crouched or unstable body positions, physical contact or attempts to follow. These are the things that reliably make adults, parents, or group members turn toward a distressed individual. An injured bird that goes silent and stays motionless is hard for predators to find, but it's also hard for allies to find. In social species, evolution tends to keep at least some noise in the system, especially in the young. The cost of attracting a predator is weighed against the benefit of summoning rescuers. Where kin or groupmates can make a difference, loud crying pays. So why stick with sound and posture in so many lineages instead of inventing emotional tears? Part of the answer is physics and ecology. Sound travels around corners, through foliage, in the dark, in tall grass, underwater. Tears don't. A drop of saline on the cornea is almost invisible beyond a few meters, especially if you're a nocturnal or crepuscular animal. A fawn hidden in weeds, a monkey high in the canopy, a mouse under leaf litter. None of them benefit from having their emotional state visible only to someone staring directly into their eyes. Sound also carries direction and distance information. A mother can triangulate the location of a screaming infant she can't yet see. A flock can orient collectively toward whoever gave the alarm. Fluid on a face doesn't tell you where to go. At best, it tells you something about the emotional state of the creature already in front of you. And then there's the risk side. A conspicuous visual signal on the face is only useful if you're already close enough for detailed inspection, and if predators aren't also reading that cue. Sound can be modulated, brief locations, scrambled calls, different intensities for different situations. Posture can shift moment by moment. Tears are binary. Either they're visible or they're not. Seen from that angle, humans are the weird ones. Most animals solve the problem of communicating distress, need and social intent by cranking up the volume and choreographing their muscles. They built cry equivalents out of screams, whimpers, crouches, nuzzles, and grooming. We somehow ended up adding a quiet, glistening overlay on top of all that. A channel of emotion that doesn't just shout into the forest, but writes itself in liquid right across the face. To understand how we got there, you have to start at the very beginning of our own story of crying. With human babies, and a sound so piercing it hijacks almost every adult nervous system on Earth. Human infants are born unfinished. Compared to most mammals, they're practically fetal on the outside. A foal can stand within an hour. A baby chimp can cling to its mother's fur from day one. Human newborns, they can't hold their own heads up. They can't regulate their temperature well. They can't move to the breast by themselves, escape danger, or even clear their own airways reliably. Biologists sometimes call this secondary altriciality, or the fourth trimester. Our huge brains and narrow pelvises forced an evolutionary compromise: deliver babies early, while their heads are still small enough to fit through the birth canal, and finish the job of development outside the womb. The cost is obvious. You get a creature that will literally die without constant, intensive care. That level of helplessness changes everything about signalling. If you're a gazelle fawn that can sprint within minutes, your main problem is staying hidden and bolting at the right moment. If you're a human infant who can't move, your main problem is summoning a caregiver. Fast, repeatedly, at all hours, with enough urgency that they don't decide to let you cry it out in Pleistocene lion country. So, from the very first hours of life, human communication is built around one brutal fact. The baby has to hijack adult nervous systems or it doesn't make it. And evolution obliged, newborns don't start with tears. For the first few weeks, sometimes months, many babies will cry loudly with completely dry eyes. That's because the lacrimal glands, the tear factories, aren't fully online yet. Reflex moisture for basic eye health is there, but the dramatic streaming we associate with crying usually comes later. The timeline is surprisingly consistent. Within minutes after birth, you get the sound, that sharp rhythmic wail driven by the brainstem and respiratory muscles. Only later in infancy do you start to see visible tear overflow during crying bouts. First a bit of shine, then small droplets, eventually full tracks running down the cheeks. In other words, the original human cry is entirely acoustic. The watery add-on is an upgrade that shows up partway through the first year of life. Meanwhile, on the other side of the interaction, adults are wired to be hacked. If you've ever felt your chest tighten or your jaw clench when a baby screams, that's not weakness. That's circuitry. Studies using brain imaging and heart rate monitoring show that infant cries light up a whole network in adults. Auditory cortex, yes, but also areas involved in threat detection, motor planning, and emotional regulation. Heart rate can jump, skin conductance spikes, hormones like oxytocin and prolactin shift, especially in parents, but not only in them. It doesn't even have to be your baby. Non-parents show similar patterns. People who say they don't like kids still have measurable physiological reactions. The sound is engineered by millions of years of selection to be hard to ignore. The qualities that make it so effective would be familiar to a bird or monkey. It's high-pitched compared to adult voices, with rapid onsets and a lot of roughness and variability. It cuts through background noise, it ramps up when ignored and modulates when comforted. Parents can quickly learn to distinguish "I'm hungry" from "I'm in pain" just from acoustic features. In that sense, human infants start out behaving like any other social animals young. They weaponize sound. But humans take the next step. As tear production increases, bouts of intense distress start to come with a new side channel, the face gets wet. You can think of this as the moment where two systems begin to overlap. On one side you have the ancient mammalian infant care machinery, hunger, separation, cold, discomfort, all funneled into loud vocal distress that activates adults. On the other, you have the eye maintenance system, glands, ducts and reflex blinking, designed to keep the cornea clean and moist. Somewhere in our lineage those two got cross-wired. One hypothesis is that emotional tears piggybacked on the infant care system first, and only later got repurposed for adult social life. In this view, the sequence might have gone something like this. Step 1. Newborns already cry vocally, and adults are already hypersensitive to that sound. Individuals whose distress also triggered a bit more lacrimal activation ended up with glossier, more reflective eyes during crying bouts. Step 2. Caregivers, who were especially responsive to that combined signal, sound plus wet, shimmering eyes, kept their offspring alive at slightly higher rates. Over many generations, genes that linked high arousal states in infants to both vocal and tear responses gained a foothold. Step 3. As brains grew more complex and social life more nuanced, that same wiring became available in older children and eventually adults. Now, tears weren't just a byproduct of infant helplessness, they were a versatile tool in the social toolkit. There's circumstantial support for this kind of story. For one thing, the stimuli that most reliably make caregivers crack are exactly the ones you'd expect if infant care circuits are being exploited. Big eyes, round faces, high voices, trembling chins, and yes, visible moisture around the eyes. Animal studies on baby schema show that exaggerated infant-like features tug on adult attention even across species. We respond to cartoon puppies and round plush toys because they echo the same template. Tears may have slotted themselves into that template as an amplifier. A dry, wailing face is urgent. A wailing face with liquid eyes and streaks down the cheeks is almost unbearable for many adults to ignore. Once visible tears were part of the infant signalling package, the door was open for something stranger. Those watery eyes didn't just tell adults, the baby needs help. They also told them something about intensity, vulnerability, surrender. And humans, unlike most animals, live in a world where relationships and reputations matter long after childhood ends. If a cue can move parents, maybe it can move partners, rivals, and friends. To see how that might have happened, you have to track what happens when a loud, unavoidable infant signal gets toned down and repurposed into a quieter, more ambiguous adult one, when evolution shifts emphasis from sound to sight. When you're a newborn in a hut, a cave, or a thatched shelter on the savannah. Noise is your superpower. When you're an adult trying not to get your entire group killed, noise can be a liability. That tension is where visible tears start to make sense. Loud crying works brilliantly when the main problem is summon a caregiver right now. Consequences be damned. A saber-tooth might hear you, but so will your mother. Evolution at that stage is willing to gamble. But as brains, weapons, and social lives get more complicated, the cost of broadcasting distress at full volume goes up. Imagine you're in a small hunter-gatherer camp, a few dozen people clustered together, predators nearby, maybe hostile neighbours over the next ridge. In that world, not every emotional crisis is something you want to announce at 90 decibels. You're terrified your partner might leave you. You feel guilty about hoarding food. You're overwhelmed by grief, but the group is already on edge. None of those are situations where screaming at top volume is a good idea. Social animals need ways to say, "I'm in trouble," without simultaneously shouting, "We're over here, come eat us." This is where shifting part of the signal from sound to sight becomes an upgrade. Tears are local, they only really register within a few meters, often within arm's reach. They're best read in face-to-face encounters, at the exact distances where subtle emotion matters most. Between lovers, between parents and older children, between friends, between subordinates and leaders. You can think of it as narrowing the broadcast radius. Infant wails flood the entire acoustic environment. Anyone with ears picks them up, ally or enemy. Visible tears, in contrast, are almost like a whisper laid over a normal speaking voice. You can still talk quietly, maintain some control over what others hear, and let the tears carry the extra payload of "this is serious" to the people right in front of you. And because tears are silent, they can be useful exactly when the stakes are highest. Picture a group hiding, listening for approaching footsteps. Voices are already low, movements controlled. If someone in that moment is overwhelmed with fear or grief, yelling is catastrophic. But wet eyes, a trembling face, a tear that finally slips down the cheek, that can communicate panic, need for reassurance, or plea for mercy without betraying your position. Evolution loves this kind of repurposing. Keep the old system sound for situations where noise is acceptable or necessary, and layer on a new channel, sight, for contexts where discretion matters. But why not just use facial expressions? Other primates already do. Chimps have fear grimaces, submissive faces, affiliative expressions. Why add literal water to the mix? One possibility is that tears are a particularly costly, and therefore particularly trustworthy, add-on. Cost matters in communication. If lying is cheap, signals become meaningless fast. In animal behavior, some of the most reliable signals are the ones that are hard to fake or actively disadvantage you while you're sending them. Biologists call these costly signals. The classic examples are things like peacocks' tails, huge, conspicuous, terrible for escaping predators. If you can survive with that, you're advertising real genetic quality. Emotional tears may be a human version of that principle, turned inward and social rather than outward and flashy. Think about what happens when you cry hard. Your eyes blur, your eyelids swell, your nose runs, your breathing gets ragged, your face contorts, your ability to see clearly and respond quickly drops. In a world where physical threats are real, that's not a neutral side effect. That's vulnerability carved into your sensory system. If someone is willing or unable not to enter that state in front of you, that tells you something. It suggests they're not about to launch an attack. They're not in peak condition for deception or violence. They're exposing themselves. That very exposure may make the signal more believable. A calculated fake cry with no physiological commitment is easy. You can raise your voice, contort your face, maybe even sob theatrically, then snap back to normal. But producing full emotional tears reliably involves autonomic processes you don't fully control. Heart rate, breathing patterns, lacrimal secretion, facial muscle activation, these are governed by brain circuits that are deeply tied to genuine arousal and distress. That doesn't mean people can never fake tears. Some can, especially with practice or particular temperaments. But across a population, the signal is noisy in a useful way. On average, visible tears correlate with real internal upheaval. They're honest enough that natural selection can still use them. The vulnerability built into tears might function like an honesty tax. If you cash in the social benefits of crying, comfort, forgiveness, leniency, you're paying in temporary helplessness. You're partially disabling your own sensory and defensive systems. That makes strategic overuse costly. There's also the matter of time. Tears don't appear and vanish as quickly as a micro-expression. They build up, track down the cheeks, leave residues. They linger long enough to be seen by multiple observers. In a tight-knit group where reputations matter, that extended visibility may increase accountability. If you break down in tears, several people might witness it and update their picture of your emotional state, not just the one person you're trying to influence. In that sense, emotional crying sits at a strange crossroads. It's less global and more controllable than infant wailing, but more committing and harder to retract than a fleeting facial twitch. Sound is the emergency siren. Tears are the sealed letter handed from one mind to another, with a little bit of your defences dissolved into the ink. Once that system exists, once you have a way to silently, expensively, and visibly display distress at close range, you've unlocked a new space of social possibilities. You can coordinate comfort and support without compromising group stealth. You can signal remorse or surrender without dropping your weapons. You can negotiate conflict and reconcile relationships using a cue that is, by design, hard to fake and hard to ignore. And that sets the stage for the next big leap in the story. Tears, not just as a distress broadcast, but as a kind of social technology for bonding, repair, and peacemaking. Once you have that kind of signal in the toolkit, evolution can start doing something sneaky with it. It can flip crying from "I am overwhelmed, help" into "we are attached, stay." In attachment theory, there's this idea of proximity-seeking behaviours. These are the things babies and children do to keep caregivers nearby, reaching out, clinging, following, protesting when they leave. But adults have their own, more subtle versions. We ask for reassurance. We share secrets. We show vulnerability in ways that pull specific people closer, rather than just broadcasting need into the void. Emotional tears fit perfectly into that category. You don't usually cry in front of just anyone. You cry to your partner, your closest friend, your family, a trusted ally, even when it feels like you're losing control. Who you allow to see you in that state is not random. It's often the people whose comfort matters the most, whose continued presence feels life or death, even if the death is social rather than physical. From an evolutionary angle, tears become a way of putting a claim on someone's time and care. If your partner sees you in tears after a fight, and they respond by sitting down, touching your shoulder, softening their tone, that moment is doing at least 3 things at once. It's reducing immediate tension. It's reminding both of you that you have a special channel of concern that doesn't exist with strangers. And it's reinforcing a behavioural pattern. When this person cries, you stay. When you stay, they attach more strongly. Multiply that across hundreds of interactions, across parents and children, lovers, friends, group members, who've bled together in hunts or battles. A pattern emerges. People who respond to tears with comfort keep relationships. People whose tears successfully pull in support survive more. lose fewer alliances, perhaps raise more viable offspring. Over deep time, some version of a cry and comfort feedback loop could become wired into our psychology. But tears aren't just about attachment in peaceful moments. They're dynamite in conflict. Think about an argument that's spiraling. Voices raised, bodies tense. Maybe the faint sense that this could tip from words into something worse. Then one person's voice cracks. They look away, their eyes flood. Suddenly the tone shifts. Even if the argument continues, it often loses some of its edge. That's the conflict de-escalation side of the story. In social mammals, there are lots of gestures that mean I yield or I'm not a threat. Lowered gaze, exposed throat, rolled back ears. In humans, tears might have been co-opted into that set of submission signals, but with an extra emotional payload. When someone cries during a confrontation, they are doing two risky things simultaneously. They're broadcasting vulnerability, blurring vision, dropping muscle tone, making themselves easier to hurt. And they're exposing internal states that are hard to disguise: fear, grief, shame, remorse. That combination is powerful because it pushes the other person into a decision point. Do you press forward against a visibly weakened, emotionally exposed target, or do you back off? In small, interdependent groups, the cost of pressing forward is high. Today's humiliated rival is tomorrow's hunting partner, co-parent, or shield between you and a predator. If your brain is tuned by natural selection to prioritize long-term cooperation over short-term dominance, signals that invite de-escalation are precious. Tears may act like a built-in off-ramp. They tell the group, if this continues, something important will break. Back down now and salvage the relationship. And this leads to another layer: reconciliation. Anthropologists studying traditional societies talk a lot about repair rituals, structured ways groups patch up conflict so they can keep functioning. It might be a formal apology, a gift exchange, a public embrace, shared food, or a joint task. The point is to move people from "we're at odds" back to "we're in this together." Emotional crying often shows up right at the hinge between rupture and repair. Think about the aftermath of a brutal argument in a family. There's a period of silence, maybe avoidance, maybe people stomping around, performing their anger. Then at some point, somebody breaks. Tears come. They say, "I didn't mean it like that," or "I'm scared," or "I don't want to lose you." That's not just catharsis. It's a social move. It creates an opening the other side can step into. They can soften, offer comfort, reaffirm the bond. In a hunter-gatherer band, where you can't just move to another apartment or block someone on social media, those openings are survival tools. You need some way to absorb the shock of aggression, jealousy, betrayal, without splintering the group every time. Tears, combined with words and body language, give you a choreography: escalation, break, visible vulnerability, comfort, renewed alliance. There's even evidence from modern psychology that shared crying episodes, grieving together at funerals, weeping with friends after collective trauma, can increase feelings of closeness and mutual trust. People report feeling more bonded to those who saw them cry, and to those whose tears they witnessed. Whether or not that maps perfectly onto the Pleistocene, it shows how tears can function as social glue right now. But glue can be messy, and not every tear gets interpreted as honest or helpful. Because crying can bring benefits, attention, forgiveness, leniency. It's always vulnerable to being used strategically. Humans are very quick to pick up on that possibility. Across cultures, you find sayings about crocodile tears, warnings about people who cry on cue, stereotypes about certain groups being manipulative with emotion. That suspicion is part of the system too. If everyone always rewarded tears blindly, the incentive to cry falsely would skyrocket, and the signal would degrade. Instead, most of us run an internal filter. We ask, often unconsciously, does this match the situation? Is this person known to overdramatic displays? Are there inconsistencies between their tears and their actions? Is this happening in private or in a high-leverage public setting? Social norms grow around those questions. In some cultures, adult men are heavily discouraged from crying except in very specific contexts: war memorials, funerals, religious experiences. The idea is that tears are so powerful as social tokens that you don't just throw them around. In other settings, public crying is normalized, even expected. But there are still rules about too much, too often, or at the wrong time. When tears violate those unwritten rules, they can backfire hard. Instead of bonding, they trigger eye-rolling, anger, or withdrawal. Instead of "this person is vulnerable and needs me," the story becomes "this person is trying to control me," or "this is emotional blackmail." That backlash is itself a kind of regulation. It keeps the crying signal hovering in a delicate equilibrium. Valuable enough to use, costly enough to deter overuse, open to interpretation enough that context always matters. Which is exactly the messy, contingent sort of arrangement you'd expect from an evolved social behaviour rather than a cleanly designed tool. So if you think of tears as social glue, they're not a simple paste you can slap on any crack. They're more like a reactive resin. They set strongest when the surface is already fit, when there is genuine attachment to work with, when the people involved are willing to be bound together again. And in situations where glue isn't enough, where conflict is about power, status, or real danger, tears slide into another role entirely. Not just bonding, but explicit surrender. That's where the "don't hurt me" side of crying really comes into focus. If you strip it down to the basics, a crying face is an appeasement package. The wetness on the cheeks, the reddening around the eyes, the way the eyelids narrow, the brows pull up in the middle, the mouth loosens, the head tilts, the gaze drops, the whole upper body often folds in a little. None of those things shout "combat ready." Across social animals, the details differ, but the logic is the same. You want a way to say, "I submit"? I'm not going to push this further in a language that's very hard to fake under pressure. Wolves lower their tails and lick at the dominant's muzzle. Primates crouch, grin nervously, avert their gaze. Humans, we have an entire facial configuration that seems tailor-made to flip a rival's brain from threat to helpless. Part of that is just what the crying face physically does to our threat detection systems. Your brain is constantly running pattern recognition on faces: angry, neutral, fearful, inviting. This isn't optional, it's baked into the visual system. There are specialized circuits in the amygdala and temporal lobes that light up faster than you can consciously think when they see widened eyes, tightened lips, raised chins, classic dominance or aggression cues. Tears scramble that pattern. In experiments where researchers digitally add tears to otherwise neutral or even slightly angry faces, people's ratings of those faces shift. The same face with a little glistening under the eyes is suddenly seen as sadder, less hostile, more in need of care. Observers are more likely to say they want to help, less likely to say they feel afraid or angry. It's as if the brain has a second rule set. If wet cheeks detected, downgrade threat level. The physiology backs this up. Other studies have shown that viewing images of crying people can dampen activity in brain regions linked to aggression and increase activity in networks associated with empathy and perspective taking. Heart rate and skin conductance, the body's arousal meters, can show a different profile when participants see tears compared to when they see dry-eyed anger. Now put that in an evolutionary context. Imagine two men in a small band locked in a status conflict. Jaw muscles flexed, shoulders squared, eyes locked. Every signal is pushing them toward a collision. Then one of them cracks. His eyes fill, his gaze breaks away, his shoulders slump. He looks suddenly smaller. On a purely physical level, he's just made himself easier to hit. Blurred vision, reduced muscle tone, compromised posture. On a social level, he's broadcasting something like, "I accept being lower in this moment. Don't destroy me. I'm yielding." If your brain is calibrated by thousands of years of group living that changes the payoff matrix, continuing to attack doesn't just win you the argument, it risks making you the kind of person everyone else needs to be protected from. And in a world where your survival depends on others choosing to share food, warn you about predators, help you when you're injured, that reputation can be lethal. Crying in that moment might lower your chance of winning the fight, but raise your chance of being kept in the group. Natural selection is not in the business of maximizing your ego, it's in the business of maximizing your inclusive fitness. Modern social psychology picks up echoes of this in how we judge criers. People who are shown fictional scenarios with a crying character versus the same scenario with a dry-eyed character tend to rate the crying version as warmer, more trustworthy, more remorseful, more approachable. They're also more likely to say that harsh punishment should be reduced, that the person has learned their lesson, that reconciliation is possible. This is not about liking tears in the abstract. It's about what tears cue: lack of threat, high emotional engagement, an open window for repair. There's also a consistent finding around helplessness. Crying individuals are seen as less capable, less in control, more in need of protection. That can be patronizing, but it's also exactly what you'd want if tears evolved to flip others from competitor mode into caretaker mode. If your goal is to stop someone from attacking you, convincing them at a gut level that you're not a rival but a burden they would feel guilty harming is a decent strategy. But strategy here doesn't mean cold calculation. For most people, the surrender signal is not conscious. You don't think, if I activate the lacrimal glands now, my opponent's prefrontal cortex will reappraise the situation. You just hit an emotional overload point and your body runs a program that by luck or selection happens to have de-escalating side effects. Of course, like everything in human behavior, it's not that simple and not that universal. Power matters. Tears coming from a subordinate to a dominant can read as submission and soften the blow. Tears coming from a dominant to a subordinate can do something very different. They can be interpreted as manipulative, as an attempt to dodge responsibility, as a way of flipping victim and aggressor roles. Culture matters too in some settings, especially those that prize emotional restraint. Crying in conflict can actually escalate things. A tearful opponent might be seen as weak, and weakness in those hierarchies can invite more aggression, not less. Or the tears might violate local norms so strongly that they trigger disgust or contempt instead of compassion. Individual differences layer on top of that. People vary wildly in how sensitive they are to others' distress. Some are high empathy responders. They see a single tear and instantly feel their own throat tighten. Others, whether through temperament, upbringing, or traits like psychopathy, experience much less of that automatic softening. For them, the surrender signal may fail or even backfire by marking someone as easy to exploit. And then there's the problem we touched on earlier: perceived sincerity. If a group has a lot of experience with tears being used as a tactical move, think of a boss who always cries when confronted, or a politician waterworking on camera, then the surrender reading gets overwritten by suspicion. Instead of "don't hurt me," the signal is decoded as "don't hold me accountable," and the response can become colder, more punitive. So the surrender signal idea isn't a magic key that explains every crying episode. It's more like one channel in a crowded radio spectrum. In situations where status is fluid, relationships are ongoing, and people are willing to see each other as long-term partners rather than disposable opponents, that wet-eyed, bowed head package can short-circuit aggression in a way that's deeply intuitive. In other contexts, the same package can be ignored, mocked, or weaponized. What's striking is that our brains are even capable of all these readings. Something as simple as a film of water over the eye doesn't just change how light refracts off the cornea. It changes how we map another person's mind, their intentions, their place in our moral universe. That kind of neural alchemy doesn't happen by accident. To really see how deep it goes, though, you have to look under the hood at the machinery that takes an emotion and turns it into salty water pouring out of your face. The weird part is that nothing in your brain was originally built for crying. Evolution doesn't sit down with a blueprint and say, let's route sorrow to the tear ducts. It takes whatever circuits are already there and starts piggybacking, repurposing, cross-wiring. So, to understand how emotion becomes water, you have to start with the control system that's in charge of almost everything you don't consciously manage, the autonomic nervous system. Most people know the cartoon version. Sympathetic is fight or flight. Parasympathetic is rest and digest. That's roughly right, but it's not on-off. They're constantly pushing and pulling on your organs, including your tear glands. When you're startled or enraged, sympathetic tone spikes. Heart rate jumps, pupils dilate, blood rushes to your muscles. That same sympathetic surge actually suppresses tear production. From an ancient survival standpoint, this makes sense. If you're grappling with a predator, this is not the moment to flood your eyes. Crying, paradoxically, is a parasympathetic heavy event. A lot of people cry not at the peak of terror, but on the calm down. After the argument, after the near miss, when the danger has passed enough that your body can afford to crash, your heart rate starts to fall, breathing becomes more irregular, you get that lump in your throat, your face flushes, your nose runs. This is your parasympathetic system slamming the brakes so hard that some functions overshoot and spill over. Tears are one of those spillovers. The actual plumbing is handled by the lacrimal glands, tucked up under the outer part of your upper eyelids. They get their marching orders through a cranial nerve pathway that runs back into the brainstem, specifically into a cluster of nuclei that coordinate facial expressions, salivation, swallowing, and, conveniently, eye lubrication. On their own, those nuclei don't care about your ex, your dead dog, or the sad movie. They respond to very basic inputs: irritation of the eye surface, dryness, certain reflex arcs. That's how reflex tears work. Dust in, tears out. To turn emotional pain into gland activity, you need the higher parts of the brain to hijack this low-level reflex machinery. The front end of that process lives in the limbic system, regions like the amygdala, anterior cingulate cortex, and parts of the insula. This is where raw feeling, threat, loss, humiliation, warmth gets tagged as important. The amygdala is constantly scanning inputs for emotional salience. The insula tracks the internal state of your body, gut churn, heart pounding, that sick heaviness in the chest. The anterior cingulate sits at the crossroads, monitoring conflict, social pain, the urge to do something. From there, signals travel down into the hypothalamus, the command center that talks directly to the autonomic nervous system. The hypothalamus decides whether you're in fight mode, collapse mode, or some messy oscillation between them. It tweaks hormones, heart rate, breathing patterns. It also has connections into the brainstem centers that control face muscles and lacrimal output. Put simply, emotion regions stir up the hypothalamus. The hypothalamus tweaks autonomic balance, and those autonomic changes hit the tear circuit. But here's where it gets more selective and more mysterious. Not all strong emotions reach that circuit in the same way. Many people report that purely cognitive frustration, say a tricky math problem, rarely makes them cry. Raw panic might lock them into a dry-eyed, hyper-alert state. What seems to hit the eyes most reliably are situations that blend high arousal with some sense of helplessness, social exposure, or meaning collapse. That pattern shows up in brain imaging too. When people are crying to sad film clips or autobiographical memories, you see not just generic emotion centers, but increased activity in regions linked to social evaluation and self-representation. Medial prefrontal cortex, temporoparietal junction, parts of the temporal polars. You're not just feeling bad, you're feeling bad about yourself in front of an imagined or actual audience. Those higher-order regions have roots down to the same hypothalamic and brainstem nodes. That might be why embarrassment, grief, moral injury, and sentimental awe are all capable of tipping you into tears, while more solitary, inward states sometimes stay dry. Neurological oddities put some guardrails around these ideas. There's a condition called pathological crying or pseudobulbar affect, often seen in people with strokes, multiple sclerosis, or certain dementias. They'll burst into tears or laughter in ways that don't match what they're feeling, and they can't turn it off. The episodes are often triggered by minor emotional or even neutral events. In these cases, the lesions usually sit in white matter tracts and brainstem areas that connect the frontal lobes with the emotional and motor centers lower down. The leading interpretation is disinhibition. The higher level systems that normally modulate your crying reflex are damaged, so the brainstem circuitry fires too easily. Flip that, and you get conditions where people almost never cry, even when they say they feel intense emotions. Certain types of frontotemporal dementia, for example, can dull both the experience and the expression of emotion. Some focal lesions in the anterior cingulate or insula seem to reduce people's tendency to tear up, though the data are sparse and messy. Then there are crocodile tears syndromes after facial nerve injuries, where nerve fibers that used to go to salivary glands regrow into the lacrimal glands instead. Now, whenever the person eats or even thinks about food, they start tearing as if they're crying. It's a reminder that the output hardware is stupidly literal. It will produce liquid when and where it's told, regardless of what you're feeling. Taken together, these cases suggest two things. First, there is a reasonably specific pathway from emotional appraisal regions, through autonomic control centers, into the brainstem networks that activate the tear glands and crying face. Damage along that route can either uncouple tears from emotion or make them fire at the wrong times. Second, that pathway isn't dedicated to sadness. It's wired into systems for social meaning, bodily state, and threat regulation more broadly, which helps explain why tears can show up at funerals, weddings, reunions, national anthems, and internet fail compilations. The brain is using the same basic machinery to broadcast very different emotional configurations. And yet, even with all this anatomy mapped out in rough strokes, we're still mostly describing the how, not the why. Knowing which nuclei light up doesn't tell you why natural selection allowed such a vulnerable, energetically costly response to become so tightly linked to our deepest feelings. To get at that, we have to zoom back out from the wiring diagram and ask what tears might be doing for the whole organism, for your stress systems, for your relationships, for the group that's watching you leak. There's a very popular story about what crying does inside your body, and you've probably heard some version of it. It goes like this: when you're stressed, your blood fills up with stress chemicals like cortisol. When you cry, those chemicals get dumped into your tears and flushed out. You literally drain the stress from your system, which is why you feel better. It's a clean, satisfying picture. It's also mostly wishful thinking. When researchers have actually compared the chemistry of emotional tears to, say, reflex tears from cutting onions, they do find differences. Emotional tears contain slightly higher levels of certain substances, prolactin, adrenocorticotropic hormone, some opioid-like molecules, a grab bag of proteins and minerals. That tells us your tear glands aren't just squirting out salt water. They're responding to the state of your body, but the dream of weeping out cortisol doesn't hold up well. For one thing, the volume is tiny. Even a big sobbing session might produce a few milliliters of fluid. The total amount of hormone you could realistically export that way is trivial compared to what's circulating in your blood and being processed by your liver and kidneys every minute. When scientists have measured stress hormones before and after crying, the results are all over the place. In some lab studies, people's cortisol levels are still high right after they've cried. Sometimes they even go up temporarily, because the emotional induction itself is stressful. If tears are a detox system, they're a surprisingly inefficient one. So why does crying so often feel like a release? Part of the answer has nothing to do with what's in the tears and everything to do with what your whole body is doing while you cry. Think about the mechanics. You're not sitting there calmly leaking. You're gulping air in jagged inhalations, then forcing it out in long exhalations. Your diaphragm is pumping. Your vocal cords are vibrating, chest and throat muscles are contracting in spasms. That pattern matters. Slow, elongated exhalations are one of the simplest ways to nudge your autonomic balance toward parasympathetic dominance. Therapists teach versions of this deliberately: sighing, box breathing, extended out breaths. Sobbing is like the messy, untrained cousin of those techniques. You get waves of sympathetic arousal, the hurt, the tightness, the gasping, followed by heavy exhale after heavy exhale. Over minutes, that can pull heart rate down and ramp up rest and digest tone. There's also something like a rebound effect. During a crisis, you might clamp down on your emotions to function, hold it together, focus. That's sustained sympathetic drive with top-down control. When the situation is finally over, after the exam, after the breakup talk, after the near accident, that control relaxes. Your parasympathetic system doesn't just drift back, it can overshoot. Blood vessels dilate, muscles go slack, you might shake, and tears come. People often describe it as, "I finally let go." Crying is embedded in that let go phase. The calming that follows may be less about chemicals washing out and more about the nervous system completing a stress cycle it's been holding off. Then there's the social layer, which is easy to ignore if you picture crying alone in a dark room, but neurologically it's central. Humans are hypersocial mammals. Our stress systems are wired to respond not just to threats, but to the presence or absence of support. When you cry in front of someone who is kind to you, who hugs you, listens, or even just sits there without judgment, you're not just venting emotion. You're triggering an entire suite of affiliative circuits: oxytocin release, safety cues, the sense of being seen instead of isolated. Studies that try to measure the after-crying effect consistently find that context matters more than the tears themselves. People who report feeling better after crying are usually the ones who cried in supportive environments, or who felt the crying helped them resolve something, gain insight, make a decision, soften a conflict. People who cried alone, felt ashamed, or made the situation worse often feel no relief, or feel worse. Which brings us to the awkward fact that doesn't fit the detox myth. A lot of people do feel worse after crying. In some surveys, a substantial minority say that crying left them more distressed, more physically drained, and more ashamed. Their heart rate may stay elevated longer. Their mood may sink. What does that tell us? It suggests that crying is not a magic valve that automatically lowers pressure. It's a high-intensity state layered on top of whatever was already going on. If the original problem is unresolved, a relationship still broken, a humiliation still raw, then diving into that state without resolution or support can amplify the badness instead of purging it. It also hints that individual differences in nervous system wiring matter. People with high anxiety, a history of trauma, or certain mood disorders may have stress systems that don't rebound cleanly. They get the activation of crying, the racing thoughts, the painful self-focus, but their parasympathetic system doesn't come in strong enough to give that soothing crash afterward. For them, crying can feel like getting stuck in the storm, not passing through it. So when we ask, do tears regulate the body? The honest answer is, indirectly and not uniformly. The act of crying plugs into multiple regulation systems, breathing rhythms, autonomic shifts, social contact, meaning-making. Under the right conditions, those systems line up and you experience the classic post-cry calm. Under the wrong ones, they don't, and the same behavior feels exhausting, embarrassing, or pointless. The chemistry in the tears is probably a reflection of those internal states more than the mechanism that changes them. That distinction between what tears are carrying and what they're communicating becomes even sharper once you zoom out from biology into behavior. Because if crying is not mainly a way to clean your blood, maybe it's a way to clean up something else. The mess between you and other people, or even between you and your own story. If tears are less about flushing chemicals and more about communication, the obvious next question is, what exactly are they saying? Because here's the strange thing. We don't just cry when we're devastated. We cry when we're overwhelmed, and overwhelmed can wear a lot of different masks. Think about the last time you cried from joy. Not polite happiness, but that chest bursting, I can't believe this is real feeling. The birth of a child. Someone walking again after an injury. A friend you thought you'd lost forever knocking on your door. The situation is positive. You're not in danger. And yet your body is doing the same tear thing it does when you're mourning a death. Or think about awe. Standing at the edge of a canyon, hearing a piece of music that feels bigger than you are, watching a launch, and realizing there are people in that fireball going into space. People describe tears in my eyes at those moments all the time. Psychologists call this family of reactions kama mutta, or being moved, sudden warmth in the chest, goosebumps, a lump in the throat, and often wet eyes. This doesn't feel like sadness hijacking the system by mistake. It feels like the system using the same output channel tears to mark something very different. This matters. Pay attention. The pattern repeats with pride. Parents at graduations. Athletes on a podium. Survivors finishing a marathon years after chemo. It's not the shallow ego boost kind of pride. It's the deep, hard-won kind that comes after effort, sacrifice, fear. People cry because the story they've been living, struggle, doubt, persistence, suddenly crystallizes into a visible result. On the darker end, there's grief and moral pain. You hear a story about someone risking their life for a stranger. You watch footage of injustice or cruelty. You read about a community rallying around someone who lost everything, that heavy, burning feeling behind your eyes. Researchers sometimes call it moral elevation when it's triggered by goodness, and moral outrage when it's triggered by horror. Both can bring tears, so now our neat sadness crying model is broken. Joy, awe, pride, grief, moral elevation, all very different flavors of experience, all converging on the same visible behavior. One way to make sense of this is to stop looking at the basic emotion words and start looking at load. Emotional load. Cognitive load. Meaning load. Many of the situations that make people cry have a few things in common. They feel high stakes for your identity, or your relationships. They carry some element of contrast or reversal, loss after security, relief after fear, beauty after numbness. And they push multiple emotional systems at once in different directions. That's what mixed feelings really are. You're not switching rapidly between happy and sad. You're running them in parallel, and your conscious mind can't quite resolve the conflict. You're proud of your kid leaving home and crushed that the little person you knew is gone. You're relieved the treatment worked and terrified of what comes next. You're stunned by human kindness in the middle of a disaster. When that stack gets too tall, the system seems to do what brains do in a lot of overload situations, spill over into a simpler, older output. Tears, sobs, that universal "I am at my limit" signal. In that sense, crying is less a specific emotion and more a punctuation mark. It doesn't tell you if the sentence was happy or sad. It tells you the sentence was important enough to underline in red. This is why tears are so tightly tied to meaning-making. The moments you remember vividly years later are often the moments you cried, or almost did. Your nervous system is basically bookmarking them. It's saying, this was a turning point. This was a value clash. This was when you realized who you are, or who someone else really is. You can feel that even privately, with no audience. People cry alone at scenes in novels, at songs that hit too close to home, at memories that line up their whole life story in a new, painful or beautiful way. No one else needs to see those tears for them to function as a kind of inner highlighter. But of course, not everyone cries at the same things. Two people can sit through the exact same movie, and only one will be a wreck by the credits. Part of that difference is temperament. Some nervous systems run hotter, more reactive, more easily flooded. What psychologists call high negative affectivity, high sensitivity, or just being thin-skinned. Those people may hit overload thresholds more quickly, so their tear response fires more often. Attachment style matters too. If you grew up with caregivers who responded to your distress with warmth and attention, crying may feel on a deep preverbal level like a safe way to seek connection. Your system learned when things get too big, show it. Someone might come. As an adult, you may find tears well up easily in close relationships, because your brain still expects that showing vulnerability can repair or strengthen bonds. If, on the other hand, your early environment punished crying, shame, mockery, withdrawal of affection, your system can go another way. You might clamp down hard on the urge to cry, or you might only be able to cry alone or only when something breaks through all your defenses. The meaning of tears for you is tangled up with danger or humiliation, not safety. Then there's learning history at the cultural level. Families, subcultures, professions all teach explicit and implicit rules when tears are acceptable, when they're manipulative, when they're heroic, when they're weak. Over years, your brain doesn't just produce tears, it predicts their consequences. If experience says crying here will bring comfort, the behavior gets reinforced. If experience says crying here will get you hurt, your system learns to route overload into something else. Anger, numbness, a joke. So the language of tears isn't a single universal dictionary. It's a biological channel, eye water plus sobbing, onto which each person's history, relationships and culture have layered a complex codebook. What seems consistent across all of that variation is this: when tears come, they are rarely about a trivial surface feeling. They tend to appear at the points in life where stories, values and relationships collide, where you're forced to decide what matters, or accept that something precious is gone, or admit that you love more, fear more, hope more than you thought. In those moments, the body doesn't give you a neatly labelled report. It gives you wet eyes and a trembling voice. It tells you, whatever this is, it's not small. And then, Once we've built that language of tears inside our own heads, we start using it on each other, reading it, judging it, rewarding it, punishing it, which is where culture steps in and rewrites the script for who gets to cry, when, and what those tears are allowed to mean. If you zoom out from individual differences and look at whole societies, something jumps out immediately. The human tear system might be biological, but the user manual is very, very cultural. Psychologists talk about display rules, unwritten guidelines that tell you which emotions you're allowed to show, to whom, and in what situations. The raw feeling might be the same in Tokyo and in Toronto, but the performance, very different. Take crying. In surveys, people in some Mediterranean and Latin American cultures report crying more often and in more public settings than people in places like Japan or the UK. It's not that Italians have more tear glands than the British. It's that the social cost of crying at a family dinner, or during a political speech, or in a church pew is different. In expressive cultures, tearing up can be read as honest, warm, passionate, fully human. In more reserved cultures, the exact same behaviour in the exact same situation can be read as loss of control, immaturity, or even rudeness, like you're dumping your emotional load on people who didn't consent. You can see display rules at work in very early childhood. Parents in different cultures respond differently to a crying toddler. Some pick them up instantly, soothing and mirroring their distress. Others wait, encourage self-control, or redirect with distraction and humour. Over thousands of such micro-events, kids are being trained. This is how much emotion you're allowed to show. This is where tears belong. By the time those kids grow up, whole professions have their own microcultures layered on top. Doctors, soldiers, judges, pilots, therapists. Each group has a sense of whether crying on the job is a sign of compassion, a liability, or a reason to take you off duty. The same pair of eyes filling with tears in a courtroom might be praised as empathy, condemned as bias, or ignored as unprofessional, depending on who's wearing the robe and which legal culture they were trained in. Layered over all of that are gender rules, which are some of the most powerful and uneven tear scripts humans have ever written. Across many societies, women report crying more frequently than men. That difference shows up in self-reports, in lab studies, and in everyday observation. There are probably multiple reasons. Hormonal influences, differences in socialization, different levels of social permission. But what's striking is not just who cries more, it's what their tears are allowed to mean. In a lot of cultures, women's tears are coded as natural, even expected in certain contexts. Grief, romantic conflict, empathy, being moved. A woman crying at a funeral or during a breakup may still be judged, but the behaviour fits a familiar script. Men's tears are more tightly policed. The same sadness that's understandable for a woman can be weak for a man. Boys are still told in many families and subcultures to man up, stop being a baby, act tough. Those phrases aren't just about volume, they're about visibility. The message is, we don't mind if you feel it, we mind if we have to see it. There are, of course, exceptions and complications. In some contexts, male tears are not just tolerated but revered. The stoic father who cries only once, at his child's birth or at a comrade's funeral, can be seen as deeply honourable. His tears are rare, so they get framed as proof of how serious the moment is. The same drops of salt water that would be mocked after a minor setback become a badge of authenticity, when timed correctly. Meanwhile, women who cry in the wrong context, say, in a high-stakes business negotiation or a political debate, can be penalised. Their tears get read as manipulation, loss of rationality, or an inability to handle pressure. Men in the same position might be criticised too, but often for different reasons, not being leaderly, not embodying the emotional armour their role supposedly requires. So the tier system itself is the same. The social consequences of pressing go are not. These rules haven't been static through history. In many ancient and medieval societies, public weeping was not just accepted, it was ritualized. Professional mourners existed in the ancient Near East, in Greece and Rome, in parts of Africa and Asia. Their job was literally to cry in public, loudly and visibly, to honour the dead and help the living express their grief. In some traditions, not crying at a funeral was the problem. It signalled disrespect, coldness, or a lack of proper attachment. Religious rituals have also used tears as a kind of spiritual currency. Medieval Christian texts describe saints weeping copiously during prayer as a sign of true repentance. Sufi mystics wrote about tears as a path to God. In some East Asian traditions, poems and plays centered around pathos were meant to evoke refined sadness, and an appropriately moved audience could be expected to tear up. The capacity to cry in response to beauty or tragedy was framed as a mark of depth, not fragility. Fast forward to many modern industrialized societies, and you see a noticeable cooling. The rise of ideals like rationalism, professionalism, and stiff upper lip restraint has made public crying more context-dependent. Tears are still allowed, even expected, at funerals, in private relationships, during national tragedies. But daily life in offices, classrooms, trains, political chambers is increasingly coded as a no-cry zone. That shift doesn't just change how often people actually cry in public. It changes what tears mean to observers when they break through the norms. In a culture where ritual wailing is normal, someone sobbing at a graveside is just doing what one does. It signals grief, but not necessarily anything special about the griever's personality. In a culture where most people stay dry-eyed, the one person who starts to shake and sob stands out. Their tears can be read as a statement: this death hits me harder, or I loved them more, or I can't cope. The same thing happens in politics and media. A leader crying on camera might once have been seen as transparent and human. In another era, in another country, the same shot gets framed as weakness or losing control, or, conversely, as a crafted performance to win sympathy. The biology hasn't changed, the interpretive lens has. That's the core power of display rules. They don't just regulate behaviour, they rewrite meaning. When a veteran cries during a remembrance ceremony, bystanders might see courage, the willingness to relive trauma and still show up. When a CEO cries during layoffs, some will see genuine remorse, others will see crocodile tears. When a child cries at school, it might be read as a simple need for comfort, or as a disciplinary problem, depending on the teacher's own history and culture. And because we're so attuned to these norms, we pre-edit ourselves. We don't just feel and then cry. We feel, then run a calculation. If I let this show here, what story will other people tell themselves about me? In that sense, culture isn't just outside of us, judging our tears from the sidewalk. It's inside the decision tree that determines whether the waterworks ever start. So by the time we watch another human face crumple, we're not only seeing a nervous system at its limit, we're seeing a collision between biology and a lifetime of training. The same tear, falling down the same cheek, can mean surrender, courage, manipulation, piety, instability, or love, depending on the rulebook in the heads of everyone watching. And that makes the mystery of human crying even deeper. It's not just that no other animal seems to use emotional tears. It's that we've taken this one basic behavior and wrapped it in so many layers of culture that to understand what a tear means, you can't just look at the eye. You have to look at the world around it. If you pull the camera even farther back, across centuries instead of just cultures, another pattern appears. Humans didn't just cry in history, they organized crying. They scheduled it, professionalized it, argued about it, outlawed it, and tried to read messages from God in it. Start with grief, because that's the most obvious place tears show up. In a lot of ancient societies, mourning wasn't a private, do this quietly in your bedroom thing. It was a public event with a script. In parts of the ancient Near East, in Jewish, Egyptian, and Mesopotamian traditions, families hired professional mourners whose job was to show up, wail, sing dirges, and cry on command. Ancient Greek funerals had women leading laments, beating their chests, tearing their hair, and yes, weeping. In some regions of Africa and Asia, you still find ritual wailers whose tears are part of the proper send-off. From a modern, individualistic perspective, that can look fake or exaggerated. But inside those cultures, the logic is almost the opposite. Grief is too big for one nervous system to carry. You outsource some of the emotional labour to the group. The dead person is important enough that the whole community should feel it, and visible tears are the proof. These rituals also solve a weird social problem. When someone dies, nobody knows exactly how much emotion is enough. Ritual crying sets a minimum standard. You don't have to guess whether it's okay to break down. The ceremony tells you, now is the time, this is the place, here's how. In some societies, not crying enough was suspicious. It could mark you as unfilial, cold, or even dangerous. Religions took that raw material and went further. They didn't just use tears, they tried to explain them. In a lot of Christian traditions, especially medieval ones, gift of tears becomes an actual phrase. Saints and mystics describe uncontrollable weeping during prayer as a sign that God's grace is working in them. Tears aren't just an emotion, they're evidence. They purify the soul, wash away sin, mark true repentance. The more you cry, the more genuine your conversion is supposed to be. Sufi writers talk about something similar. Tears as a solvent that dissolves the ego, a visible sign of longing for the divine. In some streams of Hindu and Buddhist devotion, weeping in front of an image or during chanting is taken as proof that your heart has been properly softened. Instead of pull yourself together, the message is let yourself be broken open. Philosophers wade in too, but with their own spin. In ancient Greece, some thinkers treated tears as a kind of bodily overflow that needed to be managed. The ideal citizen in some texts shouldn't be ruled by passions. Too much crying could look like a failure of reason. Later, in European Romanticism, the pendulum swings. Tears become almost fashionable, evidence that you're sensitive, deep, attuned to beauty and tragedy. The man of feeling is supposed to cry at the theatre, at poetry readings, over music. Lack of tears can be a moral defect. You're hard, shallow, unfeeling. Notice what keeps happening. The biology stays the same. The story about what tears are shifts: purification, ego death, weakness, refinement, revelation. You see the same tug of war in public life and politics. Modern audiences are used to tracking whether a leader's tears are real. A president, prime minister, or monarch crying after a disaster can be read as compassionate, human, appropriately moved. The exact same footage can also be framed, sometimes by the opposition, sometimes by the media, as staged, manipulative, or proof they're not strong enough to lead. History is full of these moments. Some rulers built reputations on self-control, never crying in public, projecting an image of steel. Others, especially in more emotionally expressive eras, leaned into tears. A general weeping over fallen soldiers, a king crying at a coronation sermon, a revolutionary leader tearing up in a speech about the people's suffering, all of that could build credibility. The logic is, if this moves him to tears, he must really care. Gender, class, and culture shape the script here too. A working-class man crying in a factory meeting might be read one way, a billionaire CEO crying on a talk show another. A female politician tearing up can be praised as relatable or attacked as unstable. The same tiny droplets carry wildly different political charges. For historians, this raises an awkward problem. So much of what we know about past weeping comes from texts, chronicles, letters, religious writings, plays, court records. These are not neutral GoPro footage of the past. They're curated stories. When a medieval monk writes that a saint wept bitterly day and night, that might be literal observation. It might also be a literary convention, a required checkbox in the genre of saint biography. When a chronicler says a king could not hold back tears on hearing bad news, was that an eyewitness account? A stock phrase to signal that he was a good, feeling ruler? A moral lesson about how a leader ought to respond? Even numbers can mislead. If one period seems awash in tearful reports and another doesn't, that doesn't automatically mean people literally cried more or less. It might mean that in that era writers thought tears were worth mentioning, or that certain kinds of tears, repentant, patriotic, maternal, had become culturally important. What historians can do is map patterns. Where are tears praised? Where are they mocked? Where are they suspicious? Which roles are allowed to cry? And when do new tear types appear in the record, like moved by a symphony or crying at a national memorial? What they can't easily do is reach into the past and measure the actual fluid coming out of actual eyes. A line in a chronicle and a wet face at a funeral are not the same kind of data. But even with that limitation, one thing is clear. As soon as humans had public life, religion, and politics, we started using tears as part of the script. We didn't just feel and leak. We built systems around leaking, rituals of grief, theologies of repentance, performance standards for rulers, turning a basic physiological response into a social technology. Which brings us back to the core mystery. If tears are so culturally overloaded, how can we possibly use history or psychology or evolution to answer the question we started with? Why do we cry at all? This is where we run straight into the limits of what science can currently prove. When you hear people say scientists don't know why humans cry, they're not completely wrong. But they're also not completely right. Part of the problem is that evolution doesn't come with a user manual. Nobody was standing next to early humans, clipboard in hand, writing, "Note, first appearance of emotional tears. Adaptive function seems to be X. What we have instead are fossils, modern brains, living behaviour, and a lot of inferential work." That's enough to rule out some ideas and support others, but it's not enough to deliver a neat, courtroom-style proof. Think about what an ideal evolutionary experiment would look like. You'd want to take two large populations of humans, let one group evolve emotional tears and keep the other group tearless, expose both to different social and environmental pressures for a few 100,000 years, and then compare survival and reproduction rates. Obviously, we can't do that. We have one species, one history, one outcome. So evolutionary scientists work backwards. They ask, given what tears do now, and the contexts where they appear, what selection pressures could have favoured them in the past? That's where you get all the theories we've been talking about. Tears as social glue, as surrender signals, as trust badges, as internal regulators of stress. Several of these can all be partly right at the same time. Traits often start as one thing and get co-opted for others. Feathers begin as insulation, then become flight surfaces. Jawbones turn into ear bones. Maybe basic eye wetting was for lubrication and infection control, then got hooked up to distress vocalizations in babies, then got visually amplified into full-on emotional weeping and folded into complex social and cultural scripts. That's a plausible pathway. Is it proven? No. It's just better or worse supported, more or less consistent with the rest of what we know about brains, hormones, and social behaviour. And even in the present, Tears are surprisingly hard to study. Most research on crying relies on self-report. You ask people, how often do you cry? What makes you cry? How did you feel after? Right away you've got problems. People forget. They round up or down. They answer in ways that fit who they think they are, or who they think you want them to be. Then there's the lab version. You bring someone into a sterile room, wire them up to measure heart rate, skin conductance, maybe hormone levels, and then try to make them cry. Show them sad films, play emotional music, read them scripts designed to trigger loss, nostalgia, guilt. Some people will tear up. Some will just get bored. Some will feel emotional but stubbornly refuse to cry because being watched changes the whole meaning of breaking down. Other people will cry in the lab but never in everyday life. And you can't exactly recreate the death of a loved one, a brutal breakup, or a moment of complete helplessness under ethically controlled conditions. So almost every piece of data about crying comes with an asterisk. This is what people say they do. This is how they cried in a lab setting. This is how a particular culture at a particular time describes tears. Cross-cultural work helps, but it has its own traps. Most psychological research historically has been weird, based on people from Western, educated, industrialized, rich, democratic societies. When scientists started doing surveys on crying frequency and attitudes, they reached first for people they had easiest access to: students, urban workers, folks willing to fill out questionnaires online. That's not the planet. That's a sliver. There are studies that include dozens of countries, and they do show patterns. For example, people in more individualistic, wealthier nations report crying more often, especially in private. But reporting isn't the same as raw behavior. Maybe in some places it's easier to admit to crying. Maybe in others you're expected to downplay it. You can't assume a blank space on the survey means dry eyes in real life. Small, remote communities are often missing from the data entirely, or show up as a handful of interviews that get generalized more than they should. Language adds another layer. Does your word for crying include quiet tearing up? Does it cover only loud sobbing? Do you count religious weeping the same way as anger tears? So when you ask, why did emotional tears evolve? Scientists are working with fuzzy behavioral measurements, patchy cultural coverage, and no time machine. Under those conditions, certainty is cheap and usually wrong. Still, this isn't a free-for-all. There are things researchers broadly agree on. They agree that reflex tears washing out dust, smoke, onion fumes are ancient and shared with many animals. They agree that basal tears, the constant film that keeps your cornea healthy, are basic maintenance, not emotion. They agree that humans are the only species we know of that reliably produces visible, overflowing tears in tight coordination with complex emotions and social contexts. Dogs look teary sometimes, elephants can have moist eyes, but consistent emotion-locked weeping is, as far as we can tell, a human specialty. They agree that emotional crying is deeply wired into brain circuits for attachment, distress, and social communication, that it often starts in infancy attached to vocal crying, and that adult weeping is heavily shaped by culture, who's allowed to cry, when, and for what. Beyond that, the field shifts from we know to this is plausible. Do tears biologically regulate stress in a way that matters for survival, or is the detox through crying story overblown? Some data suggest small hormonal changes, others say the effect is mostly subjective. Did tears evolve primarily to trigger care in others, or to signal surrender, or to synchronize group emotion, or all of the above at different stages? There's evidence pointing in each direction, but not enough to crown a single winner. That's why you keep hearing that nobody can fully explain why we cry. Not because science is clueless, but because explaining a behavior like this means threading together anatomy, hormones, brain circuits, individual psychology, and thousands of years of culture under constraints we can't cleanly control. What we have right now is a family of overlapping, partially supported stories, not a final verdict. And that grey zone between what we can say with confidence and what we're still guessing about turns out to be incredibly revealing when you look at the edge cases. The people who almost never cry, or who cry all the time, or who feel a lot but can't turn it into tears at all. So let's go there. What happens when the crying system breaks, bends, or rewires itself? Start with one of the most striking cases, people with very low empathy, including psychopathic traits. Not movie villains twirling mustaches, but clinically measured traits like shallow affect, low guilt, and difficulty feeling other people's pain. When researchers show emotionally charged scenes to people high in psychopathic traits, you often see a mismatch. They can understand what's happening. They can tell you, this is sad. This is where most people cry. Their cognitive machinery is online. But their bodies don't always join in. Heart rate, skin conductance, facial expressions, tears often flatter, blunter, or delayed. Does that mean psychopaths never cry? No. Some do, especially for themselves. Anger, frustration, self-pity. But as a group, their crying tends to be less tied to empathy and more tied to blocked goals or wounded pride. That shift is important. It suggests that emotional tears aren't just generic strong feeling coming out of the eyes. They're tuned into specific circuits for social pain, guilt, and attachment circuits that can be dialed way down. Now, flip the coin. Depression. People imagine depression as endless crying in a dark room, and for some, that's true. Increased tearfulness, crying over small triggers, feeling unable to stop once it starts. But a huge number of depressed people report the opposite. They say things like, I want to cry, but I can't. Or it's like the tears are gone. Emotional blunting. Numbness. Dry, on the inside and the outside. The paradox is that both patterns, too much crying and almost none, show up under the same diagnostic umbrella. That tells you tears aren't a simple volume knob for how sad you are. They're one output of a complex system that can misfire in different ways. Sometimes the threshold for crying drops so low that any stress floods the system. Sometimes the whole emotional network goes offline, and the tear response with it. Antidepressant medications complicate this even more. Many people on SSRIs and related drugs report reduced crying. Scenes that once made them break down now pass with a kind of detached acknowledgement. For some, that's a huge relief. For others, it feels like losing an important part of their emotional self. The drug hasn't removed sadness entirely, it's changed how easily that sadness recruits the body's older signaling channels, tears, gut feelings, tight chest. There's a mirror image on the other side, certain medications, hormonal shifts, and life stages that make crying easier, not harder. Late pregnancy, the postpartum period, puberty, perimenopause, time windows where estrogen, progesterone, and other hormones swing hard. People in these phases often say, I cry at commercials now, or I never used to be like this. The context hasn't changed much. The social meaning of the situation is the same, but the interior gain on the system is cranked up. The brain hormone tear circuit has become more excitable. Some of this may be adaptive. In the postpartum period, for example, heightened sensitivity to social cues and infant distress could be useful, even if it occasionally spills over into what we call baby blues. But when the system jumps from sensitive to chaotic, as in postpartum depression or severe premenstrual mood disorders, you see crying become less of a clear signal and more of a constant noise, not well tied to what's actually happening. Then there are people for whom the entire translation from feeling to words to tears is scrambled. Alexithymia. Alexithymia literally means no words for feelings. People with high alexithymia scores often struggle to identify what they're feeling, to label it or to link bodily sensations with emotional categories. They might notice a tight jaw, a knot in the stomach, but not easily say, "I'm sad" or "I'm ashamed." Unsurprisingly, many of them report crying less, or only in extreme states. If you can't easily recognize this as grief, the brain pathways that usually connect that recognition to tear production may fire less often, or they may fire in strange ways. Some people with alexithymia describe sudden, overwhelming crying out of nowhere because the build-up wasn't consciously noticed. Neurological conditions show similar patterns. Damage to certain brain regions, strokes or neurodegenerative diseases can cause pathological crying, bursts of tears that don't match the person's internal state at all. They're not sad, not scared, not moved, but their face is wet and their chest is heaving. The signal is now almost completely disconnected from meaning. At first glance, all this variability might look like evidence against any strong story about why humans cry. If tears can be missing in empathy disorders blunted by medication, amplified by hormones, scrambled by brain injury, doesn't that make the whole behavior feel arbitrary? It's actually the opposite. When a system fails in specific patterned ways, it gives you a kind of X-ray of how it's built. If psychopathic traits selectively reduce other-focused crying more than self-pity tears, that hints that empathy-linked circuits are especially important for socially meaningful weeping. If antidepressants dampen crying before they fully lift sadness, that suggests distinct levers for mood and tear activation. If hormones modulate how easily tears come, that tells you the cry response is wired into broader bodily states, not just abstract thoughts. The edge cases don't invalidate the idea that tears evolved as social signals and regulators. They help map the wiring diagram. They show which parts of the brain and body have to line up for a human to not just feel something, but to turn that feeling into water on the face that other people can see. And once you understand that wiring, you can start asking a deeper question. If evolution built something this intricate in us, could anything like it ever appear in another species? So let's flip the lens. Instead of asking, why are humans so weird, ask, what would it take to make another species cry like we do? Not just wet eyes from dust or onions. Not stress-induced eye irritation. Actual emotional weeping, visible fluid on the face, tied to inner states, used as a social signal. Start with prerequisites, because evolution doesn't build skyscrapers on sand. First, you probably need a certain level of social complexity. Emotional tears only make sense if someone is there to see them, interpret them, and respond in a way that changes your survival odds. Solitary predators that mostly interact by avoiding each other? Tears would be wasted. No audience, no payoff. But highly social species, elephants, cetaceans, some primates, wolves, certain birds already use elaborate vocalizations, body posture, even synchronized movement to coordinate groups and regulate conflict. They have friends and rivals. They show grief-like behavior around dead companions, tension after fights, reconciliation rituals. If tears are a "please help," "I surrender," or "we're bonded" signal, those are the kinds of social worlds where they could, in theory, be useful. Second, you need a face that matters. Humans are obsessed with faces. Our visual system devotes massive real estate to reading tiny changes around the eyes and mouth. We track micro-expressions, eye contact, pupil size, skin flushing. A streak of fluid down that canvas is going to stand out. For tears to evolve as signals, the audience has to be wired to study faces up close and care what they see. Animals that mostly communicate through smell ultrasonic sound, or whole-body motion have less incentive to develop a tiny, localized eye signal. Third, a caregiving ecology. Human infants are catastrophically helpless. They arrive early, they can't move, they can't feed themselves, they can't regulate temperature well. Their survival depends on intense, sustained parental care, and often alloparental care, grandparents, siblings, unrelated helpers. In that context, anything that makes caregivers respond faster with more investment has a huge payoff. Infant distress calls, sad faces, and eventually visible tears are all ways of hijacking adult attention. If you imagine another species evolving emotional tears, you probably want similar conditions: long childhoods, complex learning, strong attachment bonds, and lots of situations where one individual's distress is another's problem. Plenty of animals tick at least some of those boxes. Great apes, some monkeys, whales, dolphins, elephants, certain birds. Many of them live in stable groups, recognize individuals, and show caregiving well beyond simple reflex territory. So why don't we see clear emotional tearing in them, especially in those living right next to us? Because humans have been running a massive, unintentional experiment for thousands of years: domestication. Dogs share our homes. Some primates live in our facilities. Lab rodents are exposed to our medicines, our stressors, our close observation. If emotional tears were an easy add-on, if you could just bolt them onto any emotional brain, we might expect them to pop up here. Dogs already track human gaze, react to our tone of voice, show attachment behaviors, and have been selected for hypersensitivity to our cues. If any non-human was going to evolve crying to manipulate humans, you'd bet on them. But even in dogs, when you control carefully for lighting, grooming, and eye irritation, the evidence for emotional tearing is faint and controversial. Some studies suggest slight increases in tear volume when dogs reunite with owners, but we're talking subtle changes, not visible streams rolling down the fur. Nothing like the conspicuous, culturally loaded weeping you see in humans. Same story with other domesticated species. We see stress, fear, separation, anxiety, grief-like behavior. We see vocal crying, body language, withdrawal, but not a robust, repeatable pattern of tears that correlate with emotion rather than dust, infection, or chemical irritation. That tells you something important. Proximity to humans and selection for social attunement are not enough on their own. Emotional tears are not just what happens when a social animal gets extra feelings. They're more like a strange evolutionary niche. You need the right kind of eye plumbing, the right facial real estate, the right social pressures, and the right brain wiring to hook all of it together. Could convergent evolution ever put all those ingredients together again? Maybe. Nature loves to reinvent similar solutions in new lineages: wings in birds, bats, and insects, echolocation in whales and bats, camera-style eyes in vertebrates and cephalopods. There's no rule that says only one lineage gets to evolve visible emotional fluid on the face. If a highly social face-reading, long childhood species emerged with tear ducts that could be easily co-opted as a signal, you could imagine selection gradually favouring individuals whose eyes watered in very specific states: submission during conflicts, grief at separation, intense empathy during group stress. Over time, group members who responded to that signal by comforting instead of attacking, by maintaining bonds instead of defecting, would do better. The signal and the response could co-evolve, just as they seem to have in us. But we should stay cautious here. It's extremely easy to overread what we see. A seal with water on its face after hauling out. A calf with wet eyes after being separated from its mother. A dog with glistening tear lines after being scolded. Our brains rush to map our own inner life onto theirs. They're crying. They feel what I feel, in the way I feel it. Sometimes that's empathy. Sometimes it's projection. If we want to know whether any other species has or could develop something like emotional tears, we need more than vibes. We need biomarkers and better observation. That means studies that measure tear volume and composition in different emotional contexts, the way we've started to do in humans. Do stress hormones, neuropeptides, or inflammatory markers show up more in sad animal tears than in baseline tears? Are there consistent differences between, say, reunion, separation, pain, and neutral handling? It means long-term behavioral work, following individuals in naturalistic settings and asking whether visible eye wetting predicts specific social responses. Do group members treat a wet-eyed individual differently than a dry-eyed one, controlling for posture, sound, and context? And it means building guardrails against anthropomorphism, designing experiments where human observers don't know the condition of the animal, where automated systems measure tear film thickness, where we're comparing across species rather than cherry-picking the cutest examples. For now, the most honest answer is that humans are the only species we know that uses large, visible, culturally meaning-saturated tears as emotional signals. That could be a one-off evolutionary accident. It could be the first instance of a pattern that might arise again somewhere else, sometime later. Either way, the question points forward, because if we want to understand how unique we really are, we'll have to look past the wet faces that look like ours, and drill down into chemistry, circuits, and social reactions. And that brings us back to us, to the strange fact that in our species alone, emotion can turn into salty water, and that water can change what other minds do next. So, where does that leave us? We've walked through anatomy, evolution, brain circuits, social theory. We've compared humans to other animals, poked at domestication, dissected our own urge to project. We've thrown a lot of smart ideas at the wall, and notice what's still there at the centre, a gap. We have good candidates, not a verdict. Emotional tears might be social glue. They might be surrender flags. They might help regulate stress. They might be a visual amplifier for inner states that were already being broadcast by voice and posture. But there isn't a single, clean, universally accepted answer that ties every context together, from a baby's first wail, to a mourner's silent tears, to someone crying at a wedding, a protest, or a movie about a cartoon robot. Instead, we have overlapping explanations that fit some pieces well, some awkwardly, and leave others hanging. This is the point in a mystery where a lot of people get uncomfortable. We've been trained, especially by school and pop science, to think every question has a single correct solution at the back of the book. You study, you memorize, you retrieve. Biology doesn't care about that. Evolution happily builds things for one job, then quietly reuses them for others. A trait can start as a stress response, become a social signal, get folded into ritual, then get reshaped by culture and technology. By the time we show up and start asking, why is this here? There may not be one neat origin story left to tell. So if you're feeling that itch, that sense of weight, but what's the real reason we cry? That's not a failure of science. That's what a live question feels like from the inside. The real skill isn't finding a single answer. It's learning how to live with multiple plausible stories, each tested against evidence, each with blind spots, and to keep updating your map as new data come in. If that kind of uncertainty feels annoying, good. You're in exactly the right headspace to look at other places where our knowledge is surprisingly thin. Because crying is not the only everyday behaviour sitting on top of a deep hole in our understanding. Why do humans sleep the way we do, long, consolidated blocks with vivid dreams, while other mammals nap and doze on and off? Why do so many cultures invent music, and why does it hit our nervous system so hard when we can't even agree on what it does? Why do we yawn, contagious and unstoppable, across primates and even between species, with still no consensus on what it's for? If you want to go further down that kind of rabbit hole, I put together something exactly for this mindset. On the site, there's a book that dives into 12 of these unsolved puzzles, behaviours, feelings and patterns that we think we understand until we actually look at the data. Crying shows up there, but so do things like déjà vu, laughter, collective rituals, and that eerie sense of presence people report in near-death experiences and extreme isolation. Each chapter does what we're doing here, lays out the leading theories, shows where the evidence is strong, where it's shaky, and where nobody has a clue yet. No fake certainty, no, and therefore mystery solved. Just a guided tour through areas where science is still actively arguing with itself. If you're the kind of person who pauses on questions like, why do we have emotional tears at all, instead of just shrugging and scrolling, that book is basically a curated list of your next obsessions. And this week, there's a discount running for viewers of this channel. If you want to check it out, the link's in the description. You can grab the book there, read a sample chapter, see if the way it approaches mystery matches the way your brain likes to chew on questions. No pressure, obviously. You don't need it to follow the rest of this video. But if you're finding yourself replaying these ideas in your head, arguing with them, wanting to see how the same kind of reasoning applies to other weird corners of human behavior, it's there waiting for you. For now, keep that mystery mindset switched on, because we're not done with tears yet. We've talked about where they might have come from and how rare they are in the animal kingdom. Next, we're going to zoom back in on us, on what crying actually does inside a human life. When do we cry? What are we really signalling? And how does something as small as a droplet of salty water end up entangled with power, gender, culture, and history? To answer that, we have to step out of the lab and into the stories we tell about tears. So, where does all of this leave us with that original claim? Humans are the only animal that cries. If you've stayed with this all the way through, you can probably hear the asterisk now. Here's what we can say with some confidence. First, emotional tears in the strict sense, visible fluid-based weeping that shows up reliably in response to complex internal states like grief, moral injury, nostalgia, awe, or overwhelming relief seem to be uniquely human. We've looked hard for clear equivalents in other mammals and birds, especially in species with rich emotional lives and tight social bonds. We see distress calls, body language, posture changes, hormone spikes, grooming, even what looks like mourning. We don't see the same patterned link between inner emotional storms and liquid running out of the eyes. Second, that doesn't mean other animals are less emotional. It means they're using a different signalling system. Where we have tears, they have other channels. A chimp under stress screams, clings, avoids eye contact, changes its posture. An elephant around a dying family member lingers, touches, stands vigil. A dog that's scared or ashamed drops its tail, averts its gaze, changes its breathing, emits high-pitched whines. Fish, reptiles and birds all show measurable shifts in stress hormones and behavior without anything like human crying. So when people say humans are the only animal that cries, what they really mean, if they're being careful, is we're the only species we know of that routinely produces conspicuous, socially meaningful tears as part of our emotional communication system. The communication part is the solid ground. Across cultures, tears mark moments when words alone aren't enough. They draw attention, they soften faces, they force other people to update their model of what you're going through. They can signal need, help me, but also sincerity. I'm not faking this. Something real is happening inside me. That's the honesty angle. You can lie with your words. You can rehearse an apology, script a speech, practice a facial expression in the mirror. It's harder to flip your lacrimal glands on command in a way that lines up perfectly with your voice, your breathing, your skin conductance, your heart rate, your micro-expressions. Tears are messy, involuntary, and metabolically costly. They blur your vision. They make you look puffy and ready-eyed. As an evolutionary strategy, that's a weird choice if you're trying to fake your way through life. But it makes sense if tears evolved, at least in part, as a costly signal. Something that's hard to produce unless the emotion underneath is real. A visible wet receipt for inner intensity. Layered on top of that is bonding. Parents respond differently to crying infants than to neutral ones. Partners tend to respond more gently to a crying loved one than to one who's just angry and dry-eyed. In close relationships, crying episodes often mark turning points, reconciliations, confessions, decisions to stay or leave. Tears can puncture stalemates that language alone can't break. The stress regulation piece is fuzzier, but it's not nothing. Some studies suggest that crying, in certain contexts, correlates with shifts in heart rate, breathing patterns, and stress hormone levels. Not a magical detox, but a way of flipping the nervous system from a rigid, clenched state into one that's more flexible and open to social comfort. And culture wraps around all of this, like a second nervous system. Societies tell us who is allowed to cry, when, and for whom. They build rituals that channel tears, funerals, religious ceremonies, political marches, public apologies. They punish some tears as weakness and celebrate others as authenticity. Over time, those rules shape when we let tears come, when we choke them back, and even how our bodies interpret certain emotions. So the leading explanations we've walked through, communication, bonding, honest signalling, regulation, cultural shaping, aren't competing as much as they're stacking. Tears can be all of these at once. They can be a visual amplifier for emotions your voice already started broadcasting. A white flag in a conflict, signalling surrender or genuine remorse. A bridge back into connection when you've hit the limits of argument. A bodily pivot point between being overwhelmed and being comforted, and a behaviour that cultures grab onto, choreograph, and load with meaning. What don't we know? We don't know the precise evolutionary pathway. Did tears start out as a side effect of stress chemistry that later got co-opted as a signal? Or did they emerge because, in small language-using, tightly bonded groups, having a clear visual marker of inner turmoil was such a huge advantage that any random mutation nudging in that direction got rewarded? We don't know why emotional tears picked the eyes and not, say, sweat glands, skin colour changes, or some other fluid. We don't know why some people cry easily and others almost never do, even when their internal states and empathy levels look similar on paper. We don't know all the ways culture feeds back into biology. Do people in societies that stigmatize crying actually experience fewer tear episodes at the level of automatic reflex, or are they just better at suppressing them? Does chronic suppression change long-term mental health, or does it simply reroute emotional expression into different channels? We don't know whether other species have anything even vaguely parallel that we're just not measuring correctly yet. There might be subtle eye-moistening shifts in some primates that map onto specific emotional states, but nobody's looked with the right tools. Or maybe humans really did take a unique leap here, turning a basic eye maintenance system into a full-blown social technology. And we don't know how crying will change as our social world shifts. What happens to tears in an era where so much interaction is digital, where public crying can be recorded, replayed, memed and weaponized? Do we get more performative tears, fewer private ones, or something stranger? All of that uncertainty is why, even after centuries of philosophy and decades of lab work, you still see that line. Nobody can explain why humans cry. Not because there are no explanations, but because there isn't one explanation to rule them all. Just a set of overlapping stories that fit many cases, fail on others, and keep forcing us back to the data. And yet, even without a neat final answer, tears still matter. They change conversations, they shift power dynamics. They open doors to care or close them. They mark the moments in a life that get remembered, the births, the losses, the reconciliations, the quiet nights when something finally broke through. If you zoom out far enough, emotional tears are one of the strangest things our species ever did. We took water leaving the body and turned it into meaning. If you want to keep going down that road, past crying into 11 other behaviours that look simple until you actually stare at them, that's what the book I mentioned is for. It takes 12 of these prehistoric, deep-rooted mysteries and walks through the best current science on each, where the evidence is strong and where we're still guessing. You can read more about it or grab a copy through the link on the website in the description. If this kind of thing is your jam, if you like sitting with questions that don't have clean endings, do me a favour, tap like, subscribe, so you don't miss the next rabbit hole, and let me know what you think in the comments. Do you buy the idea that tears are a social signal first, and a stress release second? Do you almost never cry, or are you the person who tears up at commercials? And while you're down there, tell me where you're listening from. I love seeing these little check-ins from all over the world. It's a reminder that wherever we are, we're all carrying the same strange human hardware, the same eyes, the same brain circuits, the same capacity to leak meaning out of our faces when words stop working.